Yeah, so I'll record each day, at least the part where one of the instructors is talking, so that if you want to go back and review and get some help, you'll be able to. So all of this is on our course webpage, which is github.com/statenlab/intro to Python/wiki. So the person writing on the board is Matt Huff. He's a research associate in my lab. Other people who will be co-instructing, Bong Liu is here. She is a graduate student of mine, and Jiali Yu is right next to her. They'll both be helping out with the course. So at any point, if you want help, feel free to ask any of them as well as me. The book we'll be using is called Python for Biologists. It has a website. You do not have to purchase the book. If you go up here to this Python tutorial, we're gonna hopefully make it most of the way through this list. We might not make it quite all the way through. And this is the first 9 chapters of the book. They are offered for free. However, I really like this author. I really like supporting him. If you want to buy the book, it is a fantastic resource. We keep a couple hanging around in my lab, just floating amongst people, and we loan it out. And everyone really enjoys having it around because it's a great resource. So please consider buying it, but you don't have to for the course. Okay, so I posted a code of conduct, but it pretty much just boils down to act like a professional when you're in classroom and be respectful of everyone. We're gonna have a lot of group work, so everyone needs to treat each other with respect. And if any of you have any problems with anything, always feel free to email me or come talk to me. And my email address is at the top of this page. Since most people are enrolled, I'll go through the syllabus real quick. I will be in my office every single day this week between 3 p.m. and 4 p.m. So come see me. If that is not a convenient time for you, just shoot me an email and we will find a time that works. We'll talk a bit more about why you care about learning Python during the lecture, so I won't go through that. But I do want you to walk out of this class with a conceptual framework of programming. And even if that seems minimal, I think that that's actually a really powerful skill to have. Recognizing a text file as computer code and understanding how code is executed by a computer is the first step to not being intimidated by it. And also the first step to starting to build your knowledge and be engaged with it. So I think that's a really good thing to come out of this course. Kind of like learning a different language, I want you to also understand the fundamental parts of speech of Python. Variables, lists, strings, all those sorts of things. Again, it's so that you aren't intimidated and you can Google your way out of a problem. I still Google things. I still search for problems every single time I write a piece of code. So half of the challenge is not that you're gonna sit down, you are not going to sit down and write programs that are perfect the first time through. What you need are the skills to be able to find more information. And so that's really where we're headed, is giving you that like basic vocabulary, those building blocks that you can start using to get to the knowledge that you need. Yeah, so we will show up prepared for class. I expect all students to show up prepared for class. For this class, that pretty much just means having a laptop and a way to plug it in. We won't be doing anything much with logging into Duo like we were in last week's class, so you don't have to bring your cell phone. Let's see. Grading. Everybody wants to know, how's that going to work? So there's basically 3 ways to get points. It's on a 1 through 100 scale, kind of the typical UT A, B plus B scale. You'll get up to 25 points just for showing up to class. So those are easy. And then this is another new thing that I want to try. That I've been reading a little bit about how students synthesize information after a class period. And going back through your notes or back through the course material and thinking about it is a really great way to really cement that knowledge in your mind. So instead of a traditional homework where you try to write code or solve a problem, since it's a short course, what I want you to do is send me an email of what did I learn today. Try to synthesize the most important pieces of information that you got out of class and put them into a short email. I'll also accept a mind map. Sometimes I like to map concepts out and try to figure out how they're related. So either a few sentences or a mind map. Send me what you really got out of class. I get 5 points a day for that. And then at the end, you can either choose to do a final project script or do a quick journal review article. We will use most of the day on Friday to work on kind of a group project where you can get in small groups, pairs, whatever you want to do. And we'll try to write a script that utilizes a lot of the tools that we've learned over the course of the week. If at the end of the day you feel like I really don't think I'm there, I really don't think that I can finish the script, then you're welcome to also choose a journal article instead. And this is actually, I think, a really good outcome of this class as well, is to think about when people publish methods in a paper and say, I used Python code, and we'll talk a bit more about this later in the week. Why did they choose to write their own code? What were they trying to accomplish? Is that code reproducible? Can you find a copy of it online? So starting to think about those sorts of questions. And to me, just a one-page write-up. Maybe it's something that you came across in reading with your lab or in a journal club that you found interesting. Why did they use this Python code to do their science? And can you actually get to the script and think about what parts of the script do you understand from the course? What parts do you not understand? Do you think you can modify it to meet your own needs? And so starting to think about that is using Python as part of your research journey. And then at the very end, if you fill out the end of course survey and take a screenshot of that final page that says, thanks for filling out the survey, send me that screenshot and I'll give you 5 extra bonus points. I do really like to get feedback, and since this is the first time I've taught this course, it's extra important. So definitely let me know how it went for you. And the rest of this is pretty much university boilerplate. I do like to point out that there are lots of really great campus resources for students. If you have any questions about how to utilize these, if I don't know, I will find out. So definitely, if you haven't checked out any of those, please do. Any questions about the syllabus? Pretty standard stuff. The schedule is on this website. So each day, all of the material I go through will be here or else on that web page for the book. We're going to do some slides first, and then we're going to all sit down and work on the Python install. So don't worry about that basic setup yet. Let me run through some background information. I already told you about the book. But I didn't mention, if you buy it in a bundle, it's a little bit cheaper per book. And I really like the Advanced Python for Biologists as well. I haven't followed the Effective Python for Development, so I can't give you a recommendation on that. But if you're thinking about buying the book, maybe talk to your lab and see if anybody else wants to go in on buying a bundle, because it is a little bit cheaper. So one of the questions I get a lot is, what programming language should I learn? I hear this from graduate students all the time, so I like to just go ahead and talk about it. And my first answer is that that's actually not a very important question, surprisingly. And that's because nearly everyone who programs professionally uses more than one language. In my lab, we use R and Python and PHP and JavaScript. You use the language that you need at the time. And so learning one language is really important because that gets you 90% of the way to learning another language. It's more about learning of a way to think, a way to take a problem and break it down into iterative steps that you can tell a computer how to do. So once you can think about how to program, everything else is just syntax, and you can learn it. And most problems can be solved in any language. So this is not always true. It depends if there's like some super special package of code that you really need, you might end up using that language. Like I was just talking to one of my graduate students who was a really great R programmer, and he was telling me his new job, he's really ended up picking up more Python because they have deep learning algorithms. They just don't exist in R yet. So if you have a very specific problem that you really need to solve, a very specific base of code, maybe it matters, but 90% of the stuff out there, you can really solve it in any language. But what is important is putting in the time. If you take a course and you program a little bit and then you don't look at it for 6 months, you will forget a lot of what you've learned and you just won't get any better. Putting in regular, dedicated time to writing code, solving real problems is how you get better at coding. There's no shortcut, there's no easy, fast way. I can give you the baseline toolkit, but you're gonna have to use it and build on it. And that involves being motivated. It also really helps if you're surrounded by colleagues that can help you, so that if you have a little problem that would have maybe gotten you stuck for weeks at a time, but someone else can help you in about 2 minutes, that can really help you keep you moving forward. So one of the things that we do is we always welcome students to our lab to come ask questions. We have a lot of students come and go, so feel free to come over, talk to me, talk to my students. We don't always know the answer, but we can try to help figure it out. And this fall, I'll be doing a Tuesday afternoon Python coding 1 credit hour class. It's going to be like 4:30 to 5:30 on Tuesday. And we're just going to work through Python problems together. So kind of like a journal club, but more like a fun, let's get together, let's motivate each other to solve problems. If you're interested in building on this class, that's one opportunity. So yeah, we want to understand what it means to write code and execute scripts, understand how programmers break problems into instructions. That's probably one of the biggest parts, is taking a problem and breaking it into very small pieces. Being able to communicate with your bioinformatics colleagues is really important. So understanding what they're doing when they're writing scripts, or sending them to you to use, I think you'll get a lot of tools to facilitate that communication. And to be able to use scripts and maybe even debug or alter them. And then the last step, of course, will be to start writing your own. I get lots of emails every semester asking what classes people should be taking. These are the ones I know of. There is a course list at the Center for Environmental Biotechnology or Biology, one of the two, that is relatively up to date. There is a programming for statistical and graphical analysis of biological data. I think that one is being taught exclusively in Python now. And Jelly was a TA last year, so if you want to know all the gory details of everything you learned, she can tell you all of it. I think they really get into pandas. Is that right? That's a Python package that, if you're interested in that as a particular package, that's what that class focuses on. Karen, you might know, is the Introduction to Reproducible Data Analysis being taught? Okay. So if you're more interested in R, that could be a good option.
I don't think it's regularly offered. Sort of whenever the clamor raises.
Fair enough. So that's one to look for. That's Drew Steen in Earth and Planetary Sciences. There's also an Introduction to Programming for Scientists and Engineers. I've gotten really mixed reviews about this course from students. They try to learn like 2 or 3 languages in one semester, so it can be a little bit overwhelming, but that is out there. I've talked to some students who really liked it, so maybe ask around. Once you have a full semester of programming under your belt and you're starting to feel a little bit more confident, Scott Emmerich teaches the special topics. I think it'll be offered every other year, which I think will put it at this coming spring of 2020. And that's a really nice bioinformatics problem-driven course, so you should consider. So if you have other questions, let me know. Okay.
I don't know how to go on a big class, but it's a bioinformatics practical class. Talking about how on the biology side of things, how bioinformatics is biology.
Cool. If you want to email that to me, I'll send it out to the whole class. So nonetheless, we did end up having Python as the central focus of this class. So despite saying, oh, it doesn't matter what you pick, we picked Python, so why did we pick Python? It has a consistent syntax, which is really nice. I think that makes it a little bit easier to learn because there aren't a lot of, like you always hear about people hate learning English because there's so many special cases. Like it's always like this, except this time, this time, this time, and this time, when you conjugate the verb differently. And so syntax is important for learning. It's easier if it's consistent, and Python is very consistent, so that's nice. There are lots of great built-in libraries for doing lots of common tasks. I'll talk a little bit about that in a future day, but they do a great job with science libraries in Python. It's a very widely used language, which is mostly good because if you Google problems, you get lots of results, and that's really what you want for any sort of computer programming problem. If you have an error, if there's something you're trying to do and you can't figure out how to do it, lots of times you can just find code out on the web floating around that you can pull and test and figure out if it'll work for you. It's pretty easy to start learning. So it's not a lot of headache to just get set up. Well, you may disagree with me in 20 minutes when we try to get everybody to get Python installed on their laptops. But in general, I think it's easier than a compiled language like Java or something where you have 2 steps, you have to compile it and then run it. It's just that you just write the code and you run the code. So it should be a little bit more simple. Yeah, and we'll talk about, there's white space is important in Python, but it makes your code look very organized. And it kind of enforces Python to be readable, which is helpful if you're new, that it's not just like gobbledygook on the screen. You can kind of see the structure of the code. So that's, again, some people will say that's nice. I say that's nice. Some people think it's horrible that white space matters because it can give you a lot of errors, but we'll see how you feel about it by the end of the course. It is widely used in the scientific community, lots of scientific computing libraries. We are Ken asked specifically about BioPython last week. So I started writing a little BioPython. So we'll see it at least a little bit in this course, which is good because I think the fact that you asked about it really reminded me, like, it's good to have useful, not just basics, but also like starting to get into more useful libraries. And it has features that make it really easy to manipulate strings of characters. And it turns out that's really important for biologists because while we think of ourselves as like, oh, we're scientists, we do a lot of number stuff, we actually work a lot with text. DNA bases and protein amino acids will be the example we primarily see in this class, but manipulating text, reading in files, outputting files in different formats, manipulating text is kind of a big part of what we do, and Python's pretty good at that. So the bioinformatics field, it's not just moving from Perl to Python. I think it's fair to say that it has moved, but there's still a lot of old code floating around, Perl code floating around out there. So why did that transition happen? Which was something I was really racking my brain about 5 years ago, as I was personally trying to transition from Perl to Python. Why do I have to do this? And sometimes these things are trendy, but in this case, it made a lot of sense for the whole community to just make the shift. Because biologists need a tool to get science done, and we're really interested in a low barrier to entry and efficiency in writing code. Most biologists don't have the time or the throughput to spend, 5, 6, 7 different classes on programming, so they need something they can pick up more quickly. Python is actually a lot easier to learn. There's some empirical evidence, actually, that Python's easier to learn than Perl. And yeah, I do think there's some emphasis on the readability and the simplicity, but I also think that's balanced with a bit with the trendy factor, which is Python's quite trendy. But if you think about human languages, where like Italian and French are quite close together, if you learn one, the other one you can kind of pick up, whereas something like German or Mandarin would be quite far away. In that sense, Perl and Python, I would say, are very close. They're in the same type of family of language. So that's good to know, because if you get some Perl code, you can probably read it. It's gonna look a little funky. It's gonna have lots of semicolons, but you can probably figure it out because they're in like the same kind of general type of language. R is off in like its own category. So R and Python not gonna be that similar. Perl and Python, pretty similar. So the debate is now, do I learn Python or R? Do I use Python or R? And yeah, so R is focused on statistics and graphical models. I see it a lot more with data scientists who are, especially ecologists. A lot of ecologists are statisticians, People are really interested in quantitative modeling, those sort of questions. It's always been centered in academics and research and less in industry. So maybe there's a great infographic. I put the link that's it. So you scroll down for like many pages, and it kind of like pits R and Python against each other in many ways. But the conclusion is it's really up to you what problems you need to solve. So I think Python is really great if you want to scale up to being able to write full pieces of software or reusable scripts. R a lot of times gets used more as a command line, just like process the data and be done with it. But that's changing. R has really matured over the past few years. So there's this site that kind of looks for the popularity of languages based on code coming out and news releases, and I think they also look at job ads. And I thought this was really interesting. Python in the past year has gone from the 4th most popular language to the 3rd. Perl and R are barely hanging on at 19th and 20th most popular languages, which I was really startled because R has been traditionally very much climbing in the rankings. And in the past year, according to their analysis, it fell from 14th to 20th. I don't think this is really a death knell for R. I think R is going to be around for a long time. But I think what this does say is that Python has become incredibly popular. Yeah, I know. I think there's a lot of I honestly think that job ads influence this a lot because they need people to maintain old code. So you still see job ads for big legacy systems that use assembly language. But I don't think anybody starts a project in assembly language. Well, you know, I don't know. I've also talked to some people who work in like medical devices, and they end up writing a lot of very low level code. I had a graduate student who his original project was coding insulin pumps. And they were using assembly language because they could model it and prove that it was 100% free of bugs because it was so basic. They could actually mathematically model the code and prove to an insurance company that it was 100% bug free. So there's stuff like that out there. And this is everything. This is not just biology. Yep. So it depends on, do you care about efficiency? Do you care about speed? Do you care about, what do you care about? So I think that's why you see so many languages. We certainly have not coalesced around a single language. They also have their advantages and disadvantages. I was really surprised that like Ruby and Go and some of these other languages that I consider very new and kind of niche to be so high up on the list. But this is GitHub is an open source repo, so you can find lots of scientific code on GitHub. And Python has been holding strong in the 3rd or 4th position for a number of years. So again, I think this is great if you're just looking to look at other people's code and maybe be able to reuse it and build on it. GitHub is a great place to go, and there's lots of Python in it. I think it's really important to at least visit, like, where did this language come from? It's kind of an interesting story. Guido van Rossum is the original author of Python. He first released it in 1991, so it's actually quite a new language. It is currently developed by the Python Software Foundation, so it's kind of a big nonprofit group of people, but they have named Guido the benevolent dictator for life, which means everybody just kind of trusts him to make good decisions and steer them right. It is named after Monty Python and the Flying Circus, not after the snake, which most people don't know. And if you're not British or American, you may be like, what the heck is Monty Python Flying Circus? It was this really ridiculous British sketch comedy series broadcast by the BBC in the 70s. And it's kind of funny, so that's where the name comes from. So Guido said, I really want a language that is readable and consistent. And really he was really into having a beautiful code with English words instead of punctuation. That's going to help with the readability. And he really fought for have this white space indentation as part of the syntax. And you'll see that as we go through the course. It makes the code very organized. He actually wrote the Zen of Python, which has 20 aphorisms that the community is expected to follow. And of course, because you have to integrate that Monty Python and Flying Circus humor, he says only 19 of them have been written down. So the 20th is a mystery. But some of the aphorisms are Beautiful is better than ugly. Simple is better than complex. Complex is better than complicated. Readability counts. Special cases aren't special enough to break the rules. And if the implementation is hard to explain, it's a bad idea. So these types of things really, I think, are a great reason to think about why would biologists like this. These types of things really make sense for making a language easy to learn and share code and collaborate with others. And so the author just really tried to build these into the language from the ground up. The Python Software Foundation is a great place to go get more information. Downloads, installation instructions are there, documentation in over 70 languages, and they have a Python for Beginners lesson. We won't be going through those because we have the one specifically for biologists, but if you want more information, it's another great place. There's also the Python package index, lovingly called PyPy. It's the official repository for all your Python software packages, 49,000 packages and counting. I made these slides a few years ago, so I'm not sure if it's probably way more than 49,000 now. So if you're trying to find a package, if you're wondering, hey, maybe somebody has already written all the code to do what I want to do and I can just go get it, that's where you're going to check. So it's worth talking about, Python may well have taken over the world now, except about, let's see, 10 years ago, they went through kind of this huge messy transition. So right now we're at Python 3.7.4. That's our current stable release. 3.0 was the version that was released in 2008. So it's kind of 3 series. Python 3 series has been around for over 10 years. But the problem when they transitioned from Python 2 to Python 3 is that they did not maintain backward compatibility. So the final version of Python 2, which was released in 2010, has not been updated. And the problem has been when they transitioned to Python 3, if you use Python 3, it breaks all of the Python 2 code. And people have been writing Python code for 20 years at that point. So there's a lot of Python code out there. And then when they transitioned from 2 to 3, they broke everything, which was really kind of a huge problem. And we refer to this problem, if it's not a problem, it's backwards compatible. If it is a problem, it is not backwards compatible. And that just means that if something is backwards compatible, a software or the programming language that can successfully use interfaces and data from earlier versions of the software. So basically means it's interoperable. You can install Python 3 on your laptop but still run Python 2 code. That would have been backwards compatible. Instead, you install Python 3 on your laptop, you cannot run Python 2 code. And that has some really big disadvantages, which means you're either maintaining 2 versions of Python on your systems or you're rewriting your entire code base. So that's kind of a big problem, and it really has been, I think it vastly slowed down Python and its uptake. We're gonna stick with version 3. It's been 10 years. They finally updated BioPython. That took like five years. But you should be aware that, like, I just bought this Apple laptop 2 weeks ago and it has Python 2 on it. That's what ships with most computers still to this day. And so we're gonna install Python 3, or at least try to install Python 3. When you're writing pretty basic code, there's not a ton of changes you have to make Python 2 work, but there are some key changes. Libraries from Python 2 won't work for Python 3. So unlike most other languages where you pick up a library and it's always going to work, you need to check, did the library I just go install on my computer, is that for the version of Python that I have? They changed from using ASCII encoding of characters to Unicode encoding of characters. This is not something that's hopefully going to impact us in this class, but if you're having trouble with weird errors you can't figure out, this may be the source. We saw an ASCII error just in my class last week. It took us like 20 minutes to debug. The 2 biggest that you'll see when you're really learning Python is this division situation. For Python 2, 5 divided by 2 was 2, which I know they just give you the integer back, and they cut off the fraction and throw it away, and you have to use a percent symbol to go get the fractional remainder. That's been solved in Python 3, so you get very mathematically logical, like 5 divided by 2 is 2.5. Like, we would all agree that that's a lot more intuitive than 5 divided by 2 being 2. So I think that was a good change. They had a few little tiny things that snuck in and broke Guido's principle that special cases aren't special enough to break the rules. And one of them was print hello didn't need parentheses. It was one of the very few functions in the language that didn't need parentheses. Well, now it does. So they really went in and they went back to their aphorisms and said, anything that's a special case, we're getting rid of it. So it's either the type of really fundamental things that change between Python 2 and 3, which is why it broke all the old code. Ken? I'm going to mention it tomorrow. If you guys want to use Anaconda to install Python, you can. I kind of decided it might take too long and be too complicated, but we're going to talk about it. But not till tomorrow.
The only reason I mentioned is, and you make some good points, is the interdependencies of different types of code. So when you're trying to different, you have to know what those are. You know, what have your code right? So the things as much. When you go to Anaconda, it says, oh, okay, I'm going to run all those for you, install them. So it makes life less.
I can if you're, yeah. So I'll talk about it. I think it's definitely the next step if you're getting serious about Python, is to sort out how to use Anaconda and have different environments. It will manage a lot of your software installs. We aren't going to be doing anything terribly complicated. The only package we're going to try to install is BioPython. So that can be kind of a choose your own adventure. If you want to mess around with Anaconda outside of class and come to our lab and help you if you run into problems, that would be fine. But and this is a great XKCD Randall Munroe comic about how supposedly easy Python is to learn. And you can tell it's quite old because it uses Python. So that dates the comic. I think it's pretty cute. And this is the whole, like, the joke is, like, every time you meet somebody who loves Python, they tell you how easy it is. That's all they ever talk about. So hopefully we will find import anti-gravity is just as easy. Everything we try will be just as easy as that. When you guys click on the slides from the homepage, can you see them on Google Docs or Google Slides? Okay, great. Okay, so the next thing we're gonna do is take, I think it'll probably take around about 10 minutes. And it just depends on what kind of computer you have. You need to install Python. I installed it on my Mac really easily. Just going to the Python homepage and going to downloads and clicking on download Python 3.7.4. It should detect your operating system and give you the right version. Next, you'll need to install a text editor. It's really up to you. Don't use Word or something that is a word processor. You want something that writes plain text. The one I like for Mac is BBEdit. It's nice, it's simple, it's free. It's easy to download. I think for Windows, Notepad++. I don't know if there are any Windows users that have a strong opinion on something that's better. Yeah.
Two suggestions. One is if you install Spider, Spider is more visual-like, so it's, you want a real high-power editor, and it's free to students.
Yep.
Very, very good, very, very strong.
PyCharm costs money though, doesn't it? Okay.
My take on it is, if I can spend less time with anyone,
Absolutely. And then again, you know, some of you may want to go sit with Ken and kind of like go through his, especially if you've heard about Anaconda and you're interested in starting to use it or something like that. For those of you that don't, you can, for Mac, you have a built-in terminal that's really easy to run the code that we'll be using. It's in your applications utility folder. If you are on Windows, I'm thinking it'll be easiest to install Git Bash and then set up your environment. And that might take, I gave a link to one website I found on how to do that. But overall, what should work, you want to be able to create a file that has nothing in it except print hello. That'll be the file. And for me, I have to type Python 3. And so that's my command line. It'll then return hello. So since this, I think this is going to be a little different for everybody. I'm going to show you what that looks like so we'll all walk around and help you get set up. If you're on Windows, if you're on Mac, this is what your terminal will look like. If you install Git Bash on Windows, it will look quite similar. And I can type which Python 3. It tells me I do have Python 3. And then the other thing we'll have to do is, okay, I'm gonna change directories to my desktop. Course. So I've created a file called print.py, and I can type Python 3 print.py, and I get some stuff. So I just know Python's working. If I create a file called, if I launch BBEdit and get a new file. Yes. Yeah. All my publications are Margaret Staten. Yeah, it's kind of a common Southern thing. Yeah. Anyway, so if I say print hello, I'll call it print. You always want to name your Python code with .py, to kind of tell the computer that it's a Python script. If I save that, I get hello. So how do I make that bigger? I'll work on figuring out how to make that print2.py bigger. But this is where we want to head. So start by installing Python, installing a text editor, and installing some type of terminal. If you want to go the Anaconda method and sit at this table, move over, and we'll work on that separately. And then as you're having problems, raise your hands. And Xiaoli and Fong are both probably better at Windows than I am. And Matt and I are both always have had Mac laptops. So between the four of us, we will get you to the point where you can have a hello script, and then we'll start going through the fundamentals of Python. Yeah, okay. So, yeah, I had to do this too. If you come up with it, I'm sorry. Yeah. This is we're installing Python.
This is much more so. This is
Yeah,
so
normal.
you
Scroll
can
down.
Seems like Spider is comes with texture.
I've been actually every week. I don't know.
Okay. So when you probably need
I already did lunch.
Did you when you actually ran it?
It was.
Oh, okay. So it lives somewhere, but I don't want to do that. I don't know where it lives. Yeah, that's what I think too. So if you go back to
I will. Probably need
So I went to desktop and I created a folder called
This will get you.
you can call it first student. Maybe whole illustration. Okay. And now you want to see to that.
Yeah. Yeah.
All the examples.
But for me, it's.
I'm like,
He's so bad.
Now, do you want to can you say that? Yeah, it's that folder. Yes. Right there. Make it print up. That's okay. It's gonna work on the
that they
So I gotta change the logo. Exact same export.
yeah.
Give that a shot. You did your hello.
They show you how to do that.
Yeah, that's not
You have your hello.
So it's like a
You have your hello.
format. It's like
I'm separating value.
Yeah, how do I, like,
there's a.
is there a way to type in, like,
Okay, we're gonna write down what Aria did, and then you're gonna do it.
What I do is say, say this variable. Now you can just skip the middleman, not name it as input, but I just like to do that. Because another thing that we'll make it reusable rather than single purpose, that will be so the user will have to say, I want this tax line.
like, I'm just like, kind of going the wrong place or something, I don't know. Okay.
Good thing is just
I'm making the logical
see how I first do it. File on both sides. And then I do a read. So within the and you have to make sure that you have
Okay, raise your hand if you're not being able to print hello. Super simple. You guys are here. Just try. We'll give you one more.
so you have to make sure. See, first thing is you decide.
Pretty good. So you have to do this export path, and then you have to. So that whole thing. Another single quote.
So then you have to assign on that for the first time.
Let's do it.
And you want to do make sure you qualify. See if it was.
And I have the rest of the stuff.
Then you do file card.
Yeah.
You agree. So you first decide. You're gonna read. So first thing is you file.
Okay, so now at this point, you want to say, copy that. Well, yeah, it's export already above.
That's gonna, it's for.
And then the next one, echo.
No, it's gonna say I need a story file, just so you can say.
Greater than one.
The help code.
Oh, yeah, sorry. So it's on the code. Right.
Oh, it's saying you can't find the question is that the same thing? It's saying, I don't know.
Hopefully that means that I can log in. No, wait, hopefully.
You download, right? Okay. Up here. First. Let's start by
It's somebody's, no, it's Western State.
That's okay. Yeah, it's, and that's.
Why?
Looking at DNA and RNA stuff,
Yeah.
yes. The files are huge. And
having something that looks like this. It's nice if you can set up your screen to have your text editor on one side and your terminal on the other. And where I'm hoping that everybody is at right now is you're either typing Python or Python 3, the name of your file, whatever you named it, and you're getting hello or hello world or whatever you put in double quotes to now be appearing on the screen. So this whole thing up here, we would refer to as a statement. And in general, each line of a program is a statement. It's kind of like a sentence in English. So if you hear somebody say a statement, that's what they mean. Print is the name of our very first function. So I'm going to try to keep track of what we're learning. So we're going to learn what a function is. And the first function we're going to learn is print. So a function is a built-in part of the language that knows how to do something. In this case, print knows how to print to the screen or print something out. In this case, if functions always have parentheses. So this function print is taking a piece of information inside of those parentheses called an argument. So this is print. That is the function. We know it's a function because it has parentheses. And inside the parentheses, we're putting an argument. So that part, the hello world, is an argument. We can put another statement. I'm going to save with Control S. And now if I run it again, I should get hello world, my name is Meg. So this is a second statement using the same function, has a different argument. Okay, so the argument in this case is a string. And we just use, in computer science, we use the word string to refer to a series of characters. So kind of you can just think of it like text. And strings are always surrounded by either double quotes or single quotes. Python doesn't really care as long as you don't mix and match. So if I save that and run it again, it's happy to take UTK and single quotes and print it. But if I try to mix and match, it is not going to like that. So we could put the room number. That's my office in case you're looking for me. My editor tries to force me to have double quotes, but yours may or may not do that. But in this case, we're going to get our very first error. End of line while scanning string literal. So if you're not versed in Python speak, that's not going to make sense. But essentially what it's saying is I started with a single quote and I started looking all the way to the end of the line for the other end, that other single quote to close the string, and it couldn't find it. So say I was scanning to the end, looking for the end of the string, it started with a single quote, I'm looking for another single quote, and I didn't find it. So I'm giving you an error. So we'll get rid of the bad line. Yeah, so quotes are really important because the quotes tell the interpreter when it's reading the Python, I don't want you to try to, like, hello is not a function. World is not a function. The quotes offset, that is a string, that's an argument. In my case, I'm using, and it may be really subtle on here, BBEdit is giving me some colors, some kind of coloration to indicate that I have different parts of speech. So if I squint really closely, these prints are very dark blue or black, and these little arguments are kind of in a lighter color. So if you have Notepad++ or BBEdit, it should try to give you some of these like colors. It's called syntax highlighting. It's just an indication to help you debug your program and see what's going on. So you can tell these are strings and that your double quotes are working out okay because you have hopefully a slightly different color. If you happen to want to include quotes in your output, you can actually do that. So you could say, so if you use the double quotes to begin the string, it assumes that the end of the string is double quotes, and you can actually have single quotes inside. So, yep. Oh, I was just going to say, I was just going to reiterate what I said again, which is the very first type of quote it sees is it's like reading across your little Python code. It says, okay, I see a double quote. I expect the string to end when I see the next double quote. So it'll ignore the single quotes, and vice versa. You can swap those double and single quotes and it will print the double quotes as long as they're inside the single quotes.
One of the things that was helpful last week was
Yep, so that's going to be actually the exact same thing we saw last week, which are going to be hashtags or pound signs, depending on what decade you were born in. So in this case, a comment is basically it's a note back to yourself or someone else who's going to be using your code. It's just English notes or whatever language you want to put your notes in. I had all of this amazing French code from a French collaborator, and I couldn't read any of the comments because they were all in French. So comments can be in any language. The computer is going to ignore them. And it knows how to ignore them because it knows which lines to ignore because you have prefaced them with a pound sign or a hashtag, depending on how you like to think about that in your brain. So you can have multiple in a row, multiple comments in a row. You can have them in the middle of the code.
if you're getting comments for publication, what have you used for code comments if it's going to be published?
So at the top of the code, it's traditional to put the name of the person or people who worked on it. If it's not going to be clear to personality when it was written, I'll often put a date. I'll put a lot of comments about what does this do? What is the point of this code? This code was written to take this input, do this thing to it, and output this other thing. So I want it to be really clear and explicit about what the code's doing. And I put all of that at the top. So if someone stumbles on that and they're trying to figure out if it does what they want, they just go ahead and find that at the top. For everything else, you want to put something, you can put comments all throughout your code. Anywhere that there's a line that isn't clear or that does something important and you just want to clarify what you're doing, you can put a comment. Yep. Yeah, and it's kind of nice to put the comment right next to the code that the comment is about because they can't get disassociated, right? So if you had your documentation in one file and your code in a different file, it'd be very easy for those to not be shipped together, or you're reading part of the documentation and you're not really sure if that part of the documentation refers to which part of the code is it referring to. So just having the most important information, kind of the overview at the top, but then throughout the script, having comments is really nice. And you can think of it, comments are like a love letter to your future self. Because no matter how much you think you're gonna remember exactly why you did things the way you did them, you're not. In 6 months, you're gonna have totally forgotten what this code does. You're gonna be looking at it, it feels like a stranger wrote it. And so those comments are as much a gift to yourself as they are to other people, trust me.
Previous slide, you referenced association. Does ACM have a Stanford comments?
I don't know. Usually particular software packages or software groups will have standards that they publish. Like in bioinformatics, I know the UCSC browser has this huge document of how they are going to comment exactly how they write code and how it's going to look. So sometimes individual groups will. I'm not sure if the ACM has one overall. If you find one, email it to me and I'll send it to everyone. It's good. Okay, it may seem disappointing that we have already seen an error message, but this is actually, like, you just have to get used to error messages being a part of your life. As I mentioned earlier, nobody sits down and writes a huge chunk of code and it just magically beautifully works because they're a superstar. That's just not how it works. Usually you want to write a little tiny amount of code, test it, see if there's an error, fix the error. Add another little tiny bit, the very next step, test it, see if there's an error, debug it if there is, move on. So it should be very much baby steps, iterative development. And this is the nice thing about computer programming, as far as I'm concerned. It's not like in the lab where you may have to do 10 steps before you know if something worked, and then you have to try to figure out which of those previous 10 steps might have failed. In computing, you have the freedom to test it every single line, and it makes it much easier to figure out where things went wrong. And hopefully, you will get somewhat intelligent, interpretable feedback from the computer, not always though. So if you get something back and you just have, like maybe you read end of line while scanning string literal, and none of those words make sense to you. But if you've only added one line of code since the last time you ran the program, you know where your error is. It's somewhere in that one line. So adding very small iterative amounts of code is actually really beneficial to debugging. So I strongly recommend that. So let's look at a few more errors. So what if we forgot to use our quotes? We get invalid syntax. So this was just telling you this is not really a statement I understand. I'm not really sure what to do with this. Again, it's not smart enough to really say you need quotes, but it is telling you you've done something wrong syntactically that it doesn't like. It does give us one helpful thing. It says line 3. So if we look at our code, it's nice to have a text editor that numbers the lines. So you can see, so if you have 100 lines and tells you your error is on line 57, it's really nice to have line numbers so that you can go find that line. What happens if, let's see, okay, well, let's fix it, make sure we fix it correctly, and then we'll break it again. Okay, so now it's working. So what happens if we spelled our function name incorrectly? Now for me, I would already see like some indication that something went wrong, because when it's print, it's in black, and when it's print, it's in gray. And that might be a very subtle change, especially on the projector, but maybe on your screen you can see it. That syntax highlighting can really help you to scan your code and see what doesn't seem to be working. In this case, I get a different error. Name error, name prin is not defined. So that's just telling you, I don't know what prin is. That's not a function or a variable. Like it's not a word that I know. So in this case, that would hopefully point you toward going to that line 3 and figuring out that you need to change that function name to something that Python knows. Okay. So what happens if we wanted to say hello on one line and world on the next line? I'm going to save that and try running it. Again, we get end of line while scanning string literal. So in this case, Python really wants your entire string to be on a single line. And it's giving you the feedback, I was looking for the end of the string, I got to a new line, I hadn't found it, I'm confused. So the way that we can actually put a new line is to use a special character, /n. And then we can keep our string all on the same line. And in this case, it interprets that /n as hello and then world. So the two special characters that I use all the time are /n for new line and /t for tab. I actually currently can't think of a single other one I use, but I use new lines, I use tabs all the time. Everything else pretty much just looks, it prints like it looks. Comma prints like it looks, a period prints like it looks. But for new lines and for tabs, you want to use \n and \t. Okay, so the next important concept that we're going to learn is a variable. So let's see an example. We're going to call it my DNA. In this case, we're trying to take a piece of information and give it a tag. We're giving it a label. And that label is going to allow us to refer to that thing and do things to it. It's kind of like giving a person a name or an object a name. It is not the thing itself, it's a label of that thing, if that makes sense. So we're going to take this string, it's a set of characters, so it's a string, A, T, G, C, G, T, A, and we're going to call it, we're going to give it a label, my_DNA. And we can, at this point, start making smarter comments. In this case, it's going to wrap because I have my screen all super blown up. And maybe next we want to print it. We might give ourselves a little note. I'm going to print this next. So in this case, we're going to take that variable, that label, and we're going to give it to the print function. And instead of it printing my DNA, it's going to print the thing that my DNA refers to. It's going to print the sequence. Now, does anybody have a guess what it's going to print if I put this in quotes? Yes. So in this case, it says, okay, you put this around quotes, it's a set of characters if it's in quotes. I'm going to print exactly what you tell me in between the quotes, because it's an object into itself, and you've defined it by quotes. If I do not have quotes, it says, okay, I got to go figure out what my DNA is. It's not a string because there are no quotes. I got to go figure out what it is. And it says, oh, okay, cool. My DNA is a variable. It's a name that refers to a string. I know how to print strings. I'm going to print that string. I guess we could consider equals a function. It's an assignment operator. And it's always in the same order. So you always have the label or the variable on the left and the thing that it refers to on the right. And so the equals, like we kind of think about equals in math of two things being equivalent, and it's a short leap here of saying we're taking this label and making that label mean or refer to this object, which in this case is a string. Any questions about that? Sometimes the variables are kind of a leap in imagination. This space does not matter. In this case, white space will matter later, but not until we get to loops and conditional statements. In this case, we can get rid of these spaces, and it's not actually going to care. I think it's more readable to have the spaces, and it makes the code look a little less like cluttered and difficult to read. I think it's maybe just reading language for so long, you want to see like little clusters of characters with lots of spaces in between. Like there's no logical reason I prefer spaces, but I just think it looks nicer. Okay, so we can also change the value of a variable. Okay, so this is an important point. The Python reads from top to bottom. In this case, it said, okay, my DNA equals this A, the string that begins with A. We print it at that point in execution, that variable still refers to the string that starts with A. Then we reset the variable to refer to a different string. But because Python is reading it line by line by line, at the point that it's printing it, it still sees that the variable is equal to the string that starts with A, T, G, C, G, T, A. If we reset it to a different string, it's not going to try to print that unless, well, we can go ahead and print it again. And at this point, because it's going down iteratively line by line, we should see that second string. If we set something, just immediately reset it to something else. Again, because it's reading, this trips me up in debugging all the time, so I like to go over it a lot. Whatever, the Python does not look forward in the code. It does not look ahead of what's coming next. It just goes line by line and is doing whatever it's told as it goes down. So in this case, my DNA was equal to that ATGC GTA. On the very next line, poof, ATGC GTA is gone. Nothing refers to it. We set my DNA equal to something else, and when we go to print it, it says something else in this case. Okay, so it's worth pointing out that variable names can be anything. So we could call my DNA banana, and that would work fine. Even though banana is not a great name for this variable. Let me save that. And Python doesn't care. Python says, yep, banana is a perfectly fine name. Did you have a question, Ray? Just stretching, okay. So you can name this variable A. You can name this variable XYZ. You can name it some random word from the English language. You can name it any random set of characters. But that doesn't really help with readability of your code. It's really nice to name variables in a way that helps you figure out what that variable is storing and what that variable is meant to do. So in this case, we can start with my DNA, but maybe this is actually a restriction enzyme cut site, and so you want to call it RE site. And that's going to help you remember later when you're reading your code that that's what this variable is holding. And then when you go to print it out, it reads like print RE site. And you'll be like, oh, okay, I want to print out the restriction site. It makes it much more readable. And I said you can use anything to make up a variable name. That's not actually true. It can be letters, it can be numbers, and it can be underscores. You can't use special characters. Don't try to use like a % sign or something like that, or a $sign. None of that, no carets. You can use numbers, but numbers cannot be the first thing. It has to start with a letter. So you can use numbers and underscores later on in the variable name, but the very, very, very first thing has to be a letter. It can be an uppercase letter or it can be a lowercase letter. In this case, these are case sensitive. B-A-N-A-N-A. Yeah, thank you. Case sensitive, indeed. Oh, let me save that. Okay, and this is also to show you that the name of a variable does not relate to what's in the variable. So I can take something and call it banana, or I can create a variable called banana and it points to a DNA, right? I can name something else, banana with some random uppercase letters, and have it refer to the string lowercase banana. And those two things actually still have nothing to do with each other. The code is just going to print whatever the variable points to, and that is, it is specific to the case of the letters. So single uppercase letter can make, it's a different variable. It points to a completely different thing. Any questions about that? Okay, so let's learn how to stick strings together. I am going to get rid of all of this because we are not talking about bananas. We'll go back to my DNA so it's a little more sensible. Concatenation of strings. So when we want to stick two strings together, we can use the plus operator. And it's going to stick them together with no spaces, no new line, no nothing. It just smushes them together like glue with nothing in between. Okay, so I'll put the plus sign. Okay, we can also use multiple variables. So maybe we'll say upstream equals AAA. And you can say my DNA equals this plus upstream. So in this case, we're again just using labels to refer to strings. And if Python runs into something not in quotes, it's going to go check, is this a variable that I can go find what it refers to? In this case, it should. So we're going to create the variable upstream, assign it this string of 3 characters. Next, we're going to create a variable called myDNA. We're going to give it a string, and then we're going to concatenate that string to another string. In this case, Python's going to say, okay, what is this? Oh, it's a variable. It points to another string. I should put the AAA here in this concatenation. And again, it's going to smush them together with no space or anything. We can do this many times and in many ways. Slide it over a little. In this case, it's going to put them in the order you specified from left to right. And we can mix and match variables and string literals. So it's called a string literal if it doesn't have a variable name assigned to it. So in this case, we have a string literal. Just means it's a string, it's hanging out in the Python code all by itself, whereas this is a variable. So it's a variable pointing to a string. You can mix and match string literals, hard to say, and variables. And it doesn't care. You can mix and match. This looks like nucleotides, some English. You know, it's its own. Python doesn't know anything about DNA. At least base Python doesn't. We can eventually use BioPython, which will actually make sure that what you're doing makes sense as far as DNA sequences. But for now, it's going to let you do anything. Like you can append any characters together. You can also put all of this inside a print statement. So let's say we'll copy, I'll type it out. Okay, so I'm gonna take beginning, middle, and end. I've got 3 string literals. I've shoved them all inside my print statement. And it's gonna print beginning, middle, end. So this can be one of the most difficult things about reading Python, but as an author of Python, you will learn to love it. And that is that you can nest functions inside of each other. And it's kind of like when you learn math and you learn to start at the innermost parentheses and work your way out. It's very much the same concept. We're going to start inside the parentheses, evaluate all of that to a string, and then that entire string gets handed off to the print function to get printed. And we'll see a lot more examples of that. But just remember, start in the innermost parentheses and work your way out, and you'll be able to figure out what the code is doing. Sometimes it's easier, it's much more readable to not do that, to say my string equals beginning plus middle plus end, and then to print my string, right? Like to me, that is going to be easier. It accomplishes the exact same thing. Oh, except I can't spell. Yeah, I didn't put any of the quotes. So yeah, so that was a good example of an error. Beginning is not defined. That's not a variable. You haven't assigned that to anything. So I have to go tell it, oh, right, I meant for it to be a string literal. I want you to treat that as just a string.
I did something really weird, and now my Python console says IPC greater than.
Ooh.
And I did it by typing print. I was trying to put a space in between the word beginning and middle, and so I typed beginning plus quote backslash s quote plus middle, and now I'm in that. I just ran that on. It worked okay with backslash n.
My guess
If you don't know what it is immediately, I don't want to do it.
Try exit. Try to exit. I get you out of I guess that's not okay. Yeah, so if you're on a different, like just a regular git bash or terminal, you can always control C to just like get rid of what you have just done. If somehow you're hung, for example, like this, I have typed a command, it's expecting input, it's not getting any input, it's hung. So I can do control C. The other best way to fix things if you're just stuck is to type exit. If I type exit now, it would get rid of my terminal, and then I could just restart my terminal. So those are my 2 recommendations if you get stuck. Yeah. Yep. Yeah, no, absolutely. And we're going to do a lot more with trying to get to the point where we can write little programs where you have a problem, I'll give you some problem and you will start writing the code. And at that point, you'll be doing lots of experimentation. And that's the only way to write code. Like right now, we're kind of just going through some like very canned examples. Just so, again, I want you to kind of get familiar with like how the language reads, how it works, how the different parts go together, and just get a little bit familiar with it. But we'll get to the point of experimentation. Don't worry.
Instead of pressing run, I pressed debug, which is something in this terminal that you showed me that just wanted to get me in a whole new place that I don't.
Yeah, but you might want to be there soon. Okay, so another good function to learn might be the length function, which is shortened to len, L-E-N. And that's just something I've ended up having to memorize about Python, and it kind of varies between language if they use length as a full word or just len. In Python's case, they just use len. Okay, I'm gonna just delete all this. Okay, so I'm asking for the length of the string literal. In this case, nothing happens when I run it. I run it and I get nothing. And that's because I haven't done anything. This is the first time. So previously, the very first function we learned, print, it performs an action. It prints back to the terminal. Most functions don't have an action like that. Most functions return a value. So it creates a new object. It takes a string object and it creates a new object. In this case, it's going to return the length as a number. But for us to see that number, we need to print it out. Or we can store it in a variable. So let's store it in a variable. And then print it out. So again, the key sign that you know that it's a function is that it's followed by parentheses. The parentheses may or may not have stuff inside of them. In this case, we have put a single argument inside the parentheses, and it's a string ATGC, and we're getting the length and we're printing that length. So this also tells you that print is a pretty smart function. Print knows how to print strings. It also knows how to print numbers. Python does treat strings and numbers differently. So let's try to concatenate together a number and a string and see what happens. Well, first I'll prove to you that we can actually add two numbers. So let's say apples equals 3, oranges equals 8, fruit equals apples plus oranges. I'll get rid of all this. And it likes that line. So the plus can be used for concatenation. It can also just be used as an addition operator. So how does it work that computer science overloaded? Overloaded, I think is the word for that. This string. So these are two different, very, very different behaviors, right? So concatenation is taking these characters and putting them together to create a new string. Addition is performing a mathematical operation. We're using the same operator, but depending on the type of data it's receiving, it knows to behave in two different ways. So let's see what happens if we try to mix and match. And in this case, we've already seen print's pretty smart. I can already see I have a typo. So it knows how to print my DNA and it knows how to print DNA length. But what if we wanted to put that all on one line? We get an error. So it says type error, can only concatenate string, not int to string. So in programming, there are different types of numbers. In this case, Python has made the logical leap that this is an integer. We'll see how to use not integers, things with fractional components later. But for right now, the len function returns an integer, and general length things are in integers. So this is telling you, I don't know how to concatenate a string and an integer. I don't know, basically, do you want me to stick these things together or do you want me to perform addition? So one of the ways that we can handle this is we can convert our DNA length to a string. Oh, and this is also, like, I also wanted to point this out as a nesting operation, right? This is interesting because print knows how to print my DNA and print knows how to print DNA length. What's confused is the plus sign. So it's trying to evaluate the plus sign part, everything inside of the parentheses before it hands it off to print. So print is not confused if it gets a number and it's not confused if it gets a string. What's confused is the plus sign operator. It says, I don't know what to do. So it's trying to, the code is working from inside the parentheses out. So it's the inside of the parentheses part that's failing, not the print that's failing. Okay, so the function to convert an integer to a string is called str. And this is another place where you're going to see nesting. So it's going to start at the very most inner set of parentheses. So it's going to say, okay, I need to convert DNA length into a string. Then it's going to move out and say, I need to take this string and this other string and smush them together. We're going to use the concatenation use of the plus sign. And then all of that goes out to the very widest part of the statement, and it's going to get printed. And sometimes it's nice to make these things a little more readable. So we could even add some nice, the length is plus my DNA. Oh, the length, how about the length of my DNA is four. So, and I can go in and clean that up and add some spaces and save that. So we have a string literal being added to a variable that's holding a string, another string literal, and this is a number being converted to a string. And all of those things, because they're strings at the heart, once you finish converting this to a string, it's a string, this is a string, this variable is pointing to a string, this is a string, all of those concatenations will work, and the print is getting this argument of a single long string, and then hopefully you're seeing the length of AT is 4. And you can see, and I hadn't showed this before, you can put spaces in your strings, that's fine. Spaces are no big deal. You can still put that, if you wanted a new line before the number, you can slip that in there, and then it prints it as a new line.
If you put multiple operations together, you instead of making DNA underscore length variable, you str, use len, use line.
Yeah, absolutely. And this is the type of code you will see a lot from programmers who are in a hurry. But the more you do this, the harder it is to read, is the problem. I feel like it's worth talking about because you will find other people's code that looks like this. It's like 8 nested operations. And you have to really start from the middle and work your way out. But to me, it's a lot more readable if you don't do this. But yeah, you can nest. I mean, there's unlimited nesting opportunities. You can have 20 things nested inside of other things. All right, let me write down str as a function. So str is just a function to convert a thing to a string. It works on other, it doesn't just work on ints, it actually works on other types of things. Okay, now we're going to learn about methods. So methods are like functions, but they're slightly different. So a function is something that's understood by Python as a language. Print knows how to print many types of things. Len knows how to give you the length of many types of things. It can give you the length of a list, which we haven't learned yet, but we will. Ditto with string. It's gonna be able to operate on many things. It's kind of a core part of the language. A method, on the other hand, only functions on a certain type of object. And the way you can tell them apart is that a function is just its own keyword followed by parentheses. There may or may not be stuff inside those parentheses. A method, on the other hand, will have a variable, a period, the name of the method, and then the parentheses. So let me show you an example, and then we'll work our way through what's going on. Okay, so inside of print, I put mydna.lower. And you might have guessed from the name, what lower does is it's a method that makes all of the characters in the string lowercase. And the way that we can tell that it's a method and not a function is that it has to have a subject. It's kind of like a sentence. It needs a subject. It's what am I going to operate on? And lower only operates on strings. So you have to tell it what string you want it to operate on. I will put string 5. This is a shorthand that this is a method that works on string. Yep, there'll always be a period, there will always be parentheses. Oh, good to point out. The method does not actually change the variable, it just returns a new version of that variable. So let's see if we did mydna. And then just printed mydna. It doesn't work. And the reason why it doesn't work is because mydna.lower created a whole new object. with the lowercase letters, and then we didn't do anything with it. We didn't save it to an object. We didn't save it to a name or a variable. It just went poof into nothing. But what we can do is we can save it. We can use our assignment operator, and maybe I'll use LC for lower class, not lower class, lower capital, lower letters. MyDNA.lower. So this is going to return the string. We're going to save it into this variable, and then we can print it. Another thing worth noting that I tend to use a lot, but it can look confusing, is you can overwrite your own variable name. So let's say we really like MyDNA as a variable and we want to keep it, we can just overwrite it. And that's going to work fine. So it's going to say, MyDNA starts out pointing to capital ATCG. I'm going to take MyDNA, I'm going to use the lower method to create lowercase ATCG. I'm going to save that whole new string back into MyDNA. So I've now overwritten, just like in Excel, where like if you overwrite a cell with a new number and the old number is poof, gone, that's how you do it. So but if you want to keep the result of that method, you have to save it back into the same variable name. And let's prove to ourselves that lower only works on strings and not on ints. I mean, I don't know what a lowercase number would look like, so it doesn't make any logical sense, but let's see what that error looks like. We'll just use MyDNA length, len, MyDNA, and then if we tried to do MyDNA.lower, MyDNA length .lower. Int object has no attribute lower. So it's just telling you, you're working with an int, lower isn't defined as a thing that works on ints. So it only works on strings. So that's really the key difference between a function and a method. Function knows how to work on lots of different things. It doesn't need a subject. Methods are only going to work on one type of thing. The Python documentation is great. It's broken up into chapters where you can see all of the methods for strings and then all of the methods for integers. So it's really a nice way to learn. Oh, the Python documentation. So we go to python.org. Yeah. Apparently I have to click on docs. And I don't know if I'm not on, oh. Okay, and this is an important, so it kept asking me, do you want 2 or do you want 3? They're actually completely different sets of documentation. You have to be so careful when you're Googling things in Python, because lower is definitely a method in Python 2 and in Python 3. But if you start getting ingrained in the Python 2 documentation, it may not work if you're using Python 3. So always check which Python you're using. So we're in 3.7. You can even pick the version. And there's always other versions floating around out there. So this is pre-release and this is in development. These are for the really cutting edge programmers who are vetting code before these actual releases come out so they can make the transition and not break things, like your bank. Your bank is doing a lot of work to make sure that when new versions come out, that bank website works perfectly well and nobody's money gets lost. So those are generally not things that you need to worry about. So it is helpful to find your version. And then global module index. There's somewhere that you can find like everything about Python strings, and I don't know how to get there. But let's see, Python string methods. So see, the first thing that came up is 2.4. So I would probably want to go search and try to find the 3.7 version. But it's giving me every single Python method that has to do with strings. Capitalize, center, I don't even know what that is, count, return the number of occurrences of substring. We're going to see that hopefully today. And there's just tons. And the same thing for numbers and the same thing for ints.
And just so I know, if I
Yeah, so I would probably keep scanning. It's going to be docs.python.org. Okay, there we go. Built-in types. Yeah, the Python 3 documentation looks a lot different. String methods. So we can see they're largely similar, at least capitalized was the first on both lists. But you just never know because there's subtle but important differences between 2 and 3. So it's best to just try to make sure you've got 3 up here and not 2. I know that's really tiny, but it'll say the version number in the URL. And hopefully also at the very top, you should be able to see something. See how it has like a drop down? That's good. That's actually handy. So you could choose, you could jump amongst the documentation amongst different versions. There's also a method called upper. You can probably guess that makes it uppercase. Let's do replace. Replace is another really useful method. So basically replace is our first method that we'll see that takes two different arguments. It's basically going to take a string and it's going to replace all of the instances of one string with another string. So let's see how that works. This time we can do a protein. So let's say we wanted to replace valines with tyrosines. We could do this replace method. Oh. Caps locks, that's my problem. So in this case, we have our string. Replace is a method that operates on strings. It's going to look for all occurrences of the lowercase letter v, and it's going to replace those with the lowercase letter y.
Is this, like, what is the speed difference between doing this in Python and text editor?
When we get to regular expressions is when nothing. The answer is probably nothing. If you had to do this on a file that was like 20 gigs, it's still going to be slow. It still might be faster than your text editor. I've never tried that. But I think when you want to actually start using Python is when you have really complicated find and replaces. When you're saying, if a line starts with this one character followed by a period, then I want to remove it. But if it doesn't, then I don't want to do that. Then you get into this whole ability to do more sophisticated string manipulation. Yeah.
Another important thing is she's printing to the screen. So she just said print protein, still keeps her original string.
Right.
So she hasn't changed it.
That's a fair point. We haven't saved it. Yeah. I mean, we can save it to a variable and then do additional things to that variable. Yeah, but that could be an advantage if you wanted to have multiple copies of the data in different, where you'd replace in some cases and replace in others. Just depends on what you're trying to do. Like I said, everything we start with feels like kind of a toy example, like what's the point? But it's building. Eventually you'll be able to put all the little parts and pieces together to do things that are a little bit more interesting. Okay, replace. Okay, we're just gonna finish with replace and then we're gonna sing break. Okay, we can also replace more than one character at a time. So we could change this to have VLS replace with YMT. And in this case, it's only going to find one VLS There isn't anywhere else in here with the BLS, and it's going to replace that entire substring, the sub part of a string, it's called a substring, with YMT. And it's going to leave, like originally we had replaced two different B's with Y's, but this time this B isn't followed by an LS, so it doesn't perfectly match the substring BLS, so it gets left alone. So this time it got changed because we were only changing B's. This time it gets left alone because it wasn't followed by an LS. And yes, the original variable is not affected. If I can spell. We still have our original variable. Okay. At this point, let's take a 5-minute break, and then we're going to come back and we're going to do a couple of group exercises. Yep, 11:05. Let's call it a 6-minute break. I have another. Hey Matt, will you run and get the book, the Python for Biologists book from my office? I think it's just on the table.
Okay. Yeah, that's what I was saying. That's cool. See, that I
Yeah, I don't know if I'll have that.
or you can attribute it to some of these projecting like increases.
Your picture on the top of the screen, shouldn't that be changing?
Yeah, something's wrong with the Zoom, but it says it's still recording, so I decided to not worry about it. It probably isn't recording. I just didn't want to mess with it while we were in the middle of stuff. I noticed that at some point when I was talking, I was like, huh, look at that.